In this video, you're going to learn how to do all the different types of factoring that you're likely to encounter in an Algebra 1 or an Algebra 2 or a College Algebra course. And I'm going to show you this decision tree here so you can decide how to move through these problems and how to know what type of technique to use in any given situation. We're going to go through 30 examples together, and I'm going to show you how to approach these problems. You might want to pause the video and see if you can do the problem first on your own. And then of course, we're going to go through it together. This is probably not a beginner video. If you've never done any factoring, it might be a little bit difficult to follow. So it's good to have a little bit of a basis already. But if you take your time, you should be able to grasp this concept. So let's dive in. The first thing you want to do is you want to ask yourself, is there a greatest common factor? You might want to copy down this table or take a picture of it, and you can use this decision tree to kind of figure out what to do. Once you figure out if there's a greatest common factor, if there is one, you want to factor that out first. Then you can ask yourself, are there 2 terms, 3 terms, or 4 terms? So let's look at the first problem. In this case, is there something I can divide out of these terms? Remember, the terms are separated by plus or minus. It's basically a group. And when I look at these 2 groups, I see that they could both be divided by 2, and they both have at least one x in common. So I'm going to factor out the 2x. When I factor out the 2x, it's like doing the distributive property in reverse. So you're dividing it out. So if I was to divide this by 2x, I'd be left with 6x squared. If I was to divide this by 2x, I would just be left with 5. Now it's good to check your work. What you could do is take that 2x, distribute it into the parentheses, and you'll see that you get this original binomial back. You always want to look to see if you can factor further, but in this case, this is as far as we can go. Okay, let's take a look at example number 2 now. Now, for example number 2, we go back to our decision tree. We say, is there a greatest common factor? Meaning, is there something I can divide out of each of these terms that are separated by, plus or minus? Well, there's really nothing that's in common. So then I say, how many terms are there? Are there 2, 3, or 4? Well, there's 3 terms, 1, 2, 3. So then what I do is I look and say, following this down here, does A equal 1 or does A not equal 1? Now when I talk about A is this number here in front of the x squared term. It's in the form ax squared plus bx plus c. In this case, A is equal to 1. It's not written, but it's understood to be a 1. So what I do is I say, okay, what 2 numbers multiply to this c value, but they have to add to the b value. You might want to make a note of that for this one right here. So what multiplies to c but adds to b? In this case, it's going to be -4 and +2. -4 and +2 multiply to -8, but they add to -2. Then I just take this y squared and I write it as y and y. Now again, you can check your work by distributing the y and then distributing the -4 and then combining like terms, and you'll see that you get back this original trinomial. So these are easy ones to factor when the leading coefficient's 1, because you just say what multiplies to c but adds to b. Okay, let's look at number 3 now. Number 3, we've got 9c squared minus 64. Is there a greatest common factor? Well, it doesn't look like there's anything I can divide out of both of these. So how many terms are there? Are there 2, 3, or 4? Well, there's 2 terms. Okay, they're separated by this minus sign. So now I'm going to ask myself, is it a difference of 2 squares, or is it a sum or difference of 2 cubes? Well, this is a difference of 2 perfect squares. If I take the square root of 9 squared, I get 3c, okay, times itself, 3c. If I take the square root of 64, I get 8, okay, so I put 8 here and here, and then one of these is adding and one of these is subtracting. So sometimes it's referred to as a sum and difference pattern, and this is referred to as a difference of 2 squares or a difference of 2 perfect squares. So you factor it as a plus b, a minus b. That's what we have right here. Again, it's nice to check your work. If you FOIL this out or distribute twice, you'll get back this original binomial, so you can see if you did it right. Now, with all these different types, you always want to ask yourself, can I factor further? Because sometimes you might have to factor 2, 3, 4, 5 times to get it completely factored. But in this case, this is as far as we can go on this one. Okay, for number 4 now, we've got 125x cubed plus 1. Is there a greatest common factor? No, there's really nothing I can divide out of here except for a 1, but we're not going to count 1. Everything's divisible by 1. So how many terms are there? Well, there's 2 terms. Okay, they're separated by this plus sign. Is it a sum or difference of perfect cubes? Well, yes, this is a perfect cube because 5x times 5x times 5x. 1 is a perfect cube because 1 times 1 times 1. So I'm going to use these formulas right here. What I did is I grouped them together. So if you're adding 2 cubes, you would do addition, subtraction, and addition. If you're subtracting, you're going to subtract, add, and add. Okay, so let's go ahead and do that now. So our a value is going to be the cube root of this first term, which is just going to be 5x. Our b value is going to be the cube root of this second term, so cube root of 1 is just going to be 1. Then we've got a squared, so that's going to be 5x times 5x, that's 25x squared, minus a times b, so that's 5x times 1, so that's minus 5x, plus the last one you're always adding, that's b squared. In this case, 1 squared is just going to be 1. Now, sometimes students think that you can factor this trinomial, but you won't be able to. So it's a binomial times a trinomial, and that's as far as you can factor that one. Okay, let's look at number 5 now. By the way, I have videos on all these individual types on my Mario's Math Tutoring YouTube channel. So if you're really struggling with sum of 2 cubes or difference of 2 cubes, I have a video on that. If you're struggling with difference of 2 squares, I have a video on that. All these topics I have a video on, so you can learn more. But this is kind of trying to decide, when they're all mixed together, how do I know what to do, right? So for number 5, we've got a trinomial. Is there a greatest common factor? No, there's nothing I can divide out of all 3 terms. And again, like we said, there's 3 terms, but notice that our a value, this number in front of the squared term, is not 1. So when it's not 1, you want to ask yourself, is it a perfect square trinomial? Meaning, does it fit this pattern a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared? If it does, you factor it as a binomial squared. If it doesn't, which in this case, this one doesn't because this is not a perfect square and 10's not a perfect square. So I always check the first and the last to see if those are perfect squares. Then I look at splitting the middle term and then doing what's called factoring by grouping. So how do we split the middle term? That's this guy right here. Well, we do something called the AC method. So you take this a value times this c value and you say, what 2 numbers multiply to negative 30, but they have to add to this b value, this middle coefficient, which is positive 1. So can you think of 2 numbers that multiply to negative 30 but add to 1? Well, that's going to be 6 and negative 5. And so what we do is we use these 2 numbers to split the middle term. We're going to make this 6y and negative 5y. I'm going to bring down the negative 10 and the 3y squared. And then notice what we have now. We have 1, 2, 3, 4 terms. When you have 4 terms, you try to do it by grouping, the factoring by grouping method. So I'm going to group the first 2 and group the last 2. I'm going to factor out the greatest common factor, which is 3y. That's going to leave me with y plus 2. Here I can factor out a negative 5 as a greatest common factor, and that's going to leave me with y plus 2. Now notice there's a y plus 2 in both of these groups. I can then factor that out as the greatest common factor, and that's going to leave me with 3y minus 5. Now again, you can check your work by FOILing this out or distributing twice, and you'll get back the original. Let's take a look at number 6 now. What do you think on this one? Is there a greatest common factor? No, it doesn't look like there's a greatest common factor, but how many terms do we have? Looks like we have 4 terms, so let's see if we can just jump right in and do the factoring by grouping. So we can group these first 2, group these last 2. What can I divide out of both of these? Looks like I can divide a 4x squared out. That's going to leave me with x minus 1. Here I can factor a 5 out. That's going to leave me with x minus 1. In this group and in this group, they both have an x minus 1. If I factor out that x minus 1, I'm going to be left with 4x squared plus 5. Now remember, with factoring, you always want to see, can I factor either of these further? Well, this one's a binomial, but is it like a difference of 2 squares or a sum or difference of 2 cubes? No, it's really not. So they can't really factor that any further. That's as far as we can go, but it's always good to check. Let me erase the whiteboard and we'll do some more examples. Okay, for number 7 now, how would you factor this one? I did 30 examples in this video so we can go through some of the different types multiple times and you get some more experience. So let's look at number 7. So we've got a trinomial. there's not a greatest common factor. And notice that this leading coefficient is not 1. So we said no greatest common factor, 3 terms. A is not equal to 1. First thing I do is I check to see if it's a perfect square trinomial, meaning does it fit this pattern, a squared 2ab b squared. Well, it looks like this is a perfect square because 3y times 3y is 9y squared. This is a perfect square because 7 times 7 is 49. So all I have to do is check, does 3y times 7, that's 21y, doubled, see I'm doubling because it's 2ab, does that match 42y? Yes, it does. So that means that I can factor this as a binomial squared. It's going to be 3y minus 7, the quantity squared. If this was plus 42y, this would be plus 7. Now you can check your work because when you square something, it means you have this quantity twice, 3y minus 7 times another 3y minus 7, and you can FOIL that out or multiply that out and you'll get back the original. So that's a good one to catch because if I had to do the AC method, I have to say what 9 times 49, that's a really big number. What multiplies to that but adds to negative 42, it would be very challenging because the numbers are so large. But if you recognize and catch it's a perfect square trinomial first, you can save yourself a lot of time and energy. Okay, for number 8 now, what do you think for this one? We've got a binomial. There's not a greatest common factor. Okay, so greatest common factor, binomial. Is it a difference of 2 squares or a sum and difference of 2 cubes? Well, this one is a difference of 2 perfect cubes because I can see that 4x times 4x times 4x is 64x cubed, and 3 times 3 times 3 is 27. So in our formula here, it's going to be a is 4x and b is 3. It's a difference of 2 cubes, so I'm going to want to use this bottom sign here, so negative, positive, positive. Some students learn the acronym SOAP, same, opposite, always positive, meaning if you're subtracting, it would be the same. You'd subtract. Then the next sign would be the opposite. You would add, and the last one would be always positive. And so that's kind of a nice little way to remember the signs. So if we go ahead and substitute now, we're going to get 4x minus 3, 4x, the quantity squared, which is 16x squared. Sometimes students just write 4x squared, but it's like 4x times 4x. Plus, because it's the opposite, a times b, that's 12x, plus b squared. 3 times 3 is 9. That's as far as we can factor that one. Okay, for number 9 now, what do you think on this one? It's a trinomial, 3 terms. There's not a greatest common factor, and the a value is not 1. Also, notice that this starts with a negative. A lot of times when it starts with a negative, I like to factor that negative out first, just to kind of put it into a little bit easier to work with form. Okay, so factoring out the negative. Now, because the a is not 1, is this a perfect square trinomial? Well, we know 3y squared, that's not a perfect square. So I'm going to use the technique of splitting the middle term and factoring by grouping. So the way I do that is I take a times c, what multiplies to negative 30, but adds to positive 13. Can you think of two numbers that multiply to negative 30 but add to 13? That's going to be 15 and negative 2. So I'm going to split the middle term into 15 and negative 2, but I'm going to make sure you add the y because this has to add up back to 13y. We don't want to change the problem. We're just changing the way that it looks here. Now remember this negative, we're going to have to put that at the very end, but I'm going to do the technique of factoring by grouping. You group the first two, you group the last two. Make sure to capture whether that's positive or negative there. Now I can factor out a 3y out of both of these. So that's going to leave us with y plus 5. Here I can factor out a negative 2, and that leaves us with y plus 5. I have a y plus 5 in common that I can factor out, and that's going to leave us with 3y minus 2. And then don't forget this negative is going to come in front right here. And that's fully factored. Now, you could put the 3y minus 2 first and the y plus 5 second. It doesn't really matter because multiplication is commutative. Okay, let's look at number 10 now. We've got 4 terms. There's not a greatest common factor. 4 terms, we try factoring by grouping. So again, what we're going to do is we're going to group the first two, group the last two. What can we factor out? Looks like just an x squared. What can we factor out here? It looks like a negative 9. And because these both have a 2x plus 5 in common, we can factor that out as a group, and we're left with x squared minus 9. But remember how I said you always want to check to see if you can factor further? This is a difference of 2 perfect squares. right? So difference of two squares we factor as a sum and difference pattern. This is going to be x plus 3 and x minus 3. I'm just taking the square root of x squared, I'm taking the square root of 9, and one's adding, one's subtracting. Now it doesn't matter, you can make this one subtracting and then this one adding. Again, multiplication is commutative, and make sure to bring down the 2x plus 5. So this one we had, quite a few steps, so you want to keep factoring until you can't factor any further. For number 11, what do you think about this one? It looks like there's not a greatest common factor. There's two terms. Is it a difference of two squares, or is it a sum or difference of two cubes? Looks like we have a difference of two perfect squares. Now, here's the mistake that students sometimes make. They say, Mario, can't I just rewrite this as 144y squared minus 1? Can I just switch the order? You don't want to do that because this negative goes with this 144y squared. So it would actually look like negative 144y squared plus 1, and then it would no longer look like this difference of two squares pattern. So I would keep the order the same. Just take the square root of 1, which is 1. Take the square root of this term, which is 12y. And you can make one positive, one negative. Again, the nice thing about factoring is you can check your work by multiplying this out. And what happens, see the inside 12y, the outside negative 12y, those cancel. That's why we don't have a middle term. Let me erase the whiteboard. Let's do the next group of problems. See if you can pause the video and do these next group of problems, and we'll go through them together. So let's take a look at number 12 now. We've got 1/9 x squared minus 2/9 x minus 5/3. Now this one's interesting because we've got some fractions in here, and that kind of takes the difficulty up a notch. But first step is always to look for the greatest common factor. But when I'm dealing with fractions, I try to factor something out to basically get rid of those denominators, to get rid of those fractions. So I look at the denominators and I say, what's the least common multiple of 9, 9, and 3? Meaning, what's the smallest number that 3 goes into and 9 also goes into? That's going to be 9. So what I'm going to do is I'm going to factor out a 1/9. Okay, now when you factor out a 1/9, that's like dividing, right? But when you divide, so I don't want to change the problem, I'm going to multiply by the reciprocal. So what I'm actually going to do is I'm going to multiply by 9/1 to each of these terms. 1/9 times 9/1, that's just going to give me 1, so I get x squared. When I multiply this by 9/1, that's just going to give me 2x. And when I multiply this by 9/1, I'm going to get 45/3, which is 15. Okay, again, if you can check your work by distributing, you'll see you get back the original. But basically, when you factor that out, if you then multiply by the reciprocal, that will, that'll give you this here. Now, we want to see, can we factor further? Are there two numbers that multiply to negative 15 and add to negative 2? Because notice this leading coefficient's 1. It's a trinomial, right? And a equals 1. So we say what multiplies to c but adds to b? That's going to be negative 5 and positive 3. So this is going to factor as x minus 5, x plus 3, and make sure you bring down that 1/9. And that's fully factored. Again, you always want to look to see if you can factor further. Okay, for number 13, what do you think about this one? Now, this is a little bit more challenging because look, we've got x to the 4th and we have x squared. Now, this is what's called quote-unquote quadratic form. Quadratic means it's like an x squared, like x to the 2nd power. Would you be able to factor this if it would look like this, x squared minus x minus 42? Well, you'd say, okay, this is a trinomial. There's not a greatest common factor. Leading coefficient's 1, so it's going to factor something just like this, where I say what multiplies to c but adds to b. So what two quantities multiply to negative 42 but add to negative 1? That's going to be negative 7 and positive 6. The only difference is I'm going to make these both x squared, because x squared times x squared gives me x to the 4th. Negative 7x squared and positive 6x squared gives me negative 1x squared. And 6 times negative 7 is negative 42. So the way to recognize this pattern is whenever you see that this middle term's exponent is half of this leading term's exponent, then you know you've got a quote-unquote quadratic form type on your hands, okay? Quadratic type trinomial. So that's that one. Now again, can't factor it any further. Let's look at 14, at some more fractions. Okay, I know a lot of people hate fractions. It makes things complicated, but just kind of do what one of my professors or teachers told me back in middle school, and that was just when you see a fraction, just slow down. Just kind of put the brakes on a little bit, slow it down, and see what we need to do here. So we want to try to factor something out. And I say, what's the common multiple, the least common multiple between 16 and 4? meaning what's the smallest number 4 goes into and 16 also goes into, that's going to be 16. So I'm going to factor out a 1/16. Again, remember when you factor it out, I'm going to multiply by the reciprocal. So I'm going to multiply by 16 over 1. That's going to give me 81y squared minus 16 over 4, which is 4. Now a little bit easier to work with, I just have integers here, and I have a difference of 2 perfect squares. So I can factor the difference of 2 squares. Remember, that's our sum and difference pattern here. Take the square root of 81y squared, that's 9y. Take the square root of 4, that's 2. Remember, 1 you're adding, 1 you're subtracting, and I'm going to bring down the 1/16 here, and that's fully factored. Again, you always want to check to see if you can factor more or further. Okay, let's look at number 15 now. What do you think on this one? No greatest common factor, but we've got 4 terms, so maybe we can try factoring by grouping. Does it always work? Not always, but that's kind of the process. You want to say, well, let me check to see if I can factor by grouping. Group the first 2, group the last 2. If it starts with a negative, I like to factor that negative out. Matter of fact, I'm going to factor the negative out first, just because that's what I like to do. I think it just makes it a little bit easier. Factor the negative out of all the terms. Now we're going to factor by grouping. Make sure you capture this negative sign here. I can factor out an x squared. That leaves me with 5x minus 1. Here I can factor out a negative 16. That leaves me with 5x minus 1. Remember, when you factor out a negative, these signs are going to flip, right? Because a negative times a negative gives you back that positive 16. Now I have a 5x minus 1 in common. I can factor that out, and I'm left with x squared minus 16. Don't forget this negative here. And then this is a difference of 2 squares. Remember our sum and difference pattern. So we can factor that x plus 4, x minus 4, bring down the 5x minus 1, and this negative sign, and that's fully factored. Again, remember, square root of x squared is x, square root of 16 is 4, one's positive, one's negative. Okay, let's look at number 16 now. A little bit more challenging. What do you think about this one? Well, I notice that 8 is a perfect cube. That's 2 times 2 times 2. And this is a perfect cube. So it looks like it's a sum of 2 cubes. So that means this is going to be like my a in my formula, and b is going to be the cube root of 8, which is 2. So using the sum of 2 cubes, that's going to be the plus minus plus. These ones, the signs are on top, so the same, opposite, always positive. So I'm going to start with x plus 3y plus 2, so that's a plus b, then a squared, so that's x plus 3y, quantity squared, minus, because it's the opposite, a times b, so that's going to be x plus 3y times 2, plus, it's always positive for the last one, 2 squared, which is 4. Now you can FOIL this out and combine like terms and kind of condense it down a little bit further, but for this problem I think I'm just going to stop right here. But you can take that a little bit further, kind of clean it up by simplifying. Number 17, what do you think for this one? We've got a trinomial. There's not a greatest common factor. Leading coefficient, this a value is not 1. Well, let's check to see if it's a perfect square trinomial. Yeah, this is a perfect square because 4y times 4y. This is a perfect square because 3 times 3. All I have to do is check, does 4y times 3 doubled equal 24y? Yes, that's 12y times 2 is 24y. So this is going to be 4y plus 3, the quantity squared. See, the reason I double it is I do a times b times 2, and if it matches that middle term, I know I've got a perfect square. Now, if this was minus, this would be minus. But these are always going to be positive, the first and last term, in order to be perfect squares. So that one is easy to factor. It's just a binomial squared. So let me erase the whiteboard. Let's do the next group of problems. For number 18, what do you think? We've got 6x squared minus 11x minus 10. There's not a greatest common factor. We've got 3 terms. The leading coefficient is not 1. This is not a perfect square trinomial because 6x squared is not a perfect square. So that means we're going to split the middle term and then try the factoring by grouping. So we're going to take a times c. So what 2 numbers multiply to negative 60 but add to negative 11? This is the hardest part about the problem. Multiplies to negative 60 but adds to negative 11. That's going to be negative 15 and positive 4. So I'm going to put the x in there. So negative 15x plus 4x is negative 11x. So we're not changing the problem, just changing the way that it looks here. Factor by grouping. I can factor out a 3x. That's going to leave us with x minus 5. Here I can factor out a 2. Oh, this is a 2x here. Factor out a 2. That's going to leave us with 2x minus 5. We've got a 2x minus 5 in common that we can factor out, and we're left with 3x plus 2. Okay, let's look at number 19. So more fractions. What do you think on this one? Well, let's see if we can get rid of the denominators here by factoring out the least common multiple of 2 and 8. That's going to be 8. That's the smallest number that 2 and 8 both go into. So I'm going to factor out a 1/8, which I'm going to multiply by the reciprocal. So if I multiply by 8 over 1, that's going to give us 4y. Now I can also factor out a y. So let's factor out a y out of both groups. So 1/8 y, so that gives us 4y squared. Multiplied by 8, that's going to give us 121. Okay, now we've got a difference of two perfect squares. It's this one here. We can factor it as a sum and difference pattern. So that's going to be 2y plus 11 and 2y minus 11. And make sure you bring down the 1/8 y. And that's fully factored. Okay, for number 20, we've got kind of a big one here. But notice that this is like a group. See how these are all multiplied together? This is like a group, and they're separated by this minus sign. Now remember, the first step is always the greatest common factor. Is there something I can divide out of this group and this group? Well, it looks like I could factor out a 4, okay. Also, this one has 3x plus 2s, this one has 2x plus 2s, so we have 2x plus 2s in common, or we could say x plus 2 squared. Here I've got 2x minus 1s, 3x minus 1, so it looks like we have x minus 1 squared that we could divide out of both. And then what we're left with is going to be an x minus 1, okay. We factored out a 4, so we're going to be left with a negative 3. We're left with an x plus 2. Okay, and so now what you can do is distribute the negative 3. That's going to be negative 3x minus 6. We could combine like terms. This is going to be negative 2x minus 7. And then let's just bring these terms down. And that's fully factored. Now, one other option, you could factor out a negative 1 here and make this 2x plus 7. That might be a little bit cleaner, but that's your factored form. Okay, let's look at number 21 now. We've got a x cubed plus 216. There's not a greatest common factor. We've got two terms. Looks like it's a sum of two perfect cubes. So that's going to be this one right here. And I can see this is 6 times 6 times 6. That's 6 cubed. So a would be x, and b would be 6. And so if I factor this, it's going to be a plus b, a squared, minus, because remember it's the opposite, a times b, so 6 times x, plus b squared. 6 squared is 36. That's as far as you can factor that. Again, sometimes students think, oh, maybe I can factor this trinomial, but you won't be able to. And then for 22 now, we've got a trinomial. There's not a greatest common factor. The leading coefficient's 1. These are the easy ones. You just say what multiplies to c but adds to b, right? So what two numbers multiply to 12 but add to 7? That's just going to be 3 and 4. And again, you can check your work. See, 3y plus 4y gives you the 7y. This gives you 12, and this gives you the y squared back. Let me erase the whiteboard. Let's do the next group of problems. See if you can do these next group of problems on your own, and we'll go through them together. And while you're doing that, I want to let you know that I've got 2 video courses for sale, an Algebra 1 and an Algebra 2 / College Algebra video course for sale. I've got links in the description. I take you through both of those courses in 85 to 87 videos each, going over the concepts, example problems, and problems for you to work on your own. So check those out if you need help with those courses. Also, now you can join as a member to Mario's Math Tutoring. So Mario's Math Tutoring YouTube channel, the community members, you can join at the additional videos level to get access to over 120 videos now. I've got my geometry course on there, my ACT and SAT courses on there. I've got midterm and final exam reviews and additional videos there as well. So check that out if you want some more content and you're enjoying this, this channel. But let's go back into these problems now with factoring. We've got 4 terms. There's not a greatest common factor, so we're thinking factoring by grouping. So if we group these first 2 and group the last 2 and pull out that greatest common factor, what does that give us? Here we can factor out a negative 4. If it starts with a negative, I always factor out the negative. Okay, that's important. And then you can see we've got the 3x minus 1 in common. I can factor that out. And we're left with x squared minus 4. This is a difference of two squares, so I can factor it further, x plus 2, x minus 2. So you can see with factoring, you always want to check to see if you can go further. Just keep going back to the decision tree and keep asking yourself, can I factor more? For 24, what do you think about this one? It's a trinomial. There's not a greatest common factor. Leading coefficient's not 1. Is it a perfect square trinomial? Well, let's check. 25y squared, that's 5y times 5y. 49, that's 7 times 7. Is 5y times 7 doubled 70y? Yeah, it is. That's 35y doubled to 70y. Now, because this is negative, this is going to be minus, and the quantity squared. If this was plus 70y, this would be plus 7. So that was kind of an easy one if you recognize it's a perfect square trinomial. For number 25, same thing, a trinomial, not a greatest common factor in there. Leading coefficient's not 1, but this is not a perfect square trinomial. So we're going to do our AC method. What multiplies to 84 but adds to negative 25? That's going to be negative 21 and negative 4. So I'm just splitting that middle term, okay, into negative 21x and negative 4x. And then now what we can do is factor by grouping because we have 4 terms. So I factor out the 7x, we get x minus 3. And if I factor out the negative 4, x minus 3 again, we can factor out that x minus 3 as a greatest common factor, and we're left with 7x minus 4, and that's fully factored. Okay, let's look at number 26 now. This one's a trinomial, 3 terms, not a greatest common factor. Leading coefficient's 1, that's nice, but notice that this is x to the 6th and x to the 3rd. When this middle term's exponent's half of this leading term's exponent, it's what's called, quote unquote, a quadratic form, in quadratic form. And it's going to be factored just like this. So I'm going to say, what multiplies to negative 8 but adds to 7? That's going to be positive 8 and negative 1. And I'm going to make these both x cubed, because x cubed times x cubed is x to the 6th. And this gives us 8x cubed, negative 1x cubed, which is the middle term, 7x cubed. But we always want to ask if we can factor further. Now notice this is a sum of 2 cubes, and this is a difference of 2 cubes. So we have to factor these further. Now our a is going to be x and our b is going to be 2. I'm going to be using this sum of 2 cubes formula. So it's going to be a plus b, a squared minus ab plus b squared. 2 squared is 4. This is a difference of 2 cubes, so it's going to be a minus b, a squared plus ab. 1 times x is just going to be 1x plus b squared. 1 squared is 1. Can I factor it further? No, that's as far as I can go. That's fully factored. Okay, how about for number 27? Not a greatest common factor, 2 terms. Is it a difference of 2 squares or a sum of, or a difference of 2 cubes? It looks like it's a difference of 2 squares because the square root of 81 squared is 9y. Square root of 100 is 10. And we just make one positive, one negative. Again, this works because you get 90y and negative 90y, which cancels, which means you don't have a middle term. You just have a first and a last. Let me erase the whiteboard. Let's do the last few problems. Okay, see if you can do these last 3 problems. Number 28, we've got 6x squared minus x minus 15. It's a trinomial. There's not a greatest common factor. Leading coefficient's not 1. But it's not a perfect square trinomial because this is not a perfect square. So let's do our AC method. What 2 numbers multiply to negative 90 but add to the middle coefficient negative 1? And we'll split the middle term. So multiplies to negative 90 but adds to negative 1. So that would be negative 10 and positive 1. And make sure to put the x in there. Bring down the first and last term. And now we can factor by grouping. I can factor out a 2x. Let's see, is that right? I can factor out a 2x. Oh, this is negative 10 and positive 9. Yeah, that adds up to negative 1. Good. So factor out a 2x. That's going to be 3x minus 5. Here I can factor out a 3. So that's going to give us 3x minus 5. We've got the 3x minus 5 in common we can factor out. And that's left with 2x plus 3. And that's fully factored. Okay, for 29, what do you think on this one? We've got a trinomial. There's not a greatest common factor. Leading coefficient's not 1, but this is a perfect square. See, 6y times 6y is 36y squared. 121 is also a perfect square because 11 times 11. What we have to check is a times b times 2, does that match this middle term? Well, 6y times 11 is 66y, doubled is 132y. So this is a perfect square trinomial, which is factored as a binomial squared. If this was minus, this would be minus. But this is plus, so you're adding. Again, you can check it by writing this twice and filling it out. Okay, last problem. We've got a trinomial. Leading coefficient's 1. There's not a greatest common factor. This one's kind of an easy one. We just have to say what multiplies to the c value but adds to the b value. So can you think of two numbers that multiply to 48 but add to negative 19? This would be negative 16 and negative 3. That multiplies to 48, but the negative 16x and negative 3x give you the negative 19x. So great job if you're able to follow this video. If you want more practice, I've got a video where you actually go through 100 problems, okay? And I have a free worksheet that you can download. So you can download, do the problems, and look at the video solutions and get some practice. So I'll put that video right there for you. Follow me over to that video. I look forward to seeing my other videos, and I'll talk to you soon.